Welcome everyone to this episode of Energy in Our Society. Today we're going to be looking at Green Mountain College in Poultney, Vermont. Here a select group of students have come together to figure out their energy efficiency of their light bulbs outside. Let's go take a look. Now, in order to start making connections between energy usage and energy efficiency, we have to look at how these lights work. And for this, we've brought in our group mate, Max, who's going to show us over the next couple days how they work.
LEDs are commonly used today from anything from computer screens to holiday decorations. LED stands for light emitting diode. In these lights, the chemicals present in the bulb emit light when an electrical current is passed through them. The color of a light depends on what chemical is present in the bulb. In this particular kind of LED light, there is a ballast in the fixture that requires a fan to prevent the fixture from overheating. This fan reduces efficiency in these kind of fixtures, and by replacing the 80 fixtures with higher efficiency ballast, this campus could save a lot more power. High pressure sodium lights are commonly used in outdoor lighting and have a characteristic orange glow. In a high-pressure sodium light, a tube made of aluminum oxide contains several gases that are kept under high pressure. There are electrodes at each end of a tube. When a pulse start of electricity is sent through the tube, the gases ignite one by one until they vaporize. The light that is produced results from the gases reacting with the electric current.
Now the real question is, approximately how much energy do these lights use in a given year? To figure this out, we go to our next group mate, Elizabeth. Now Elizabeth is going to tell us some of the calculations. So to begin, how many LEDs and high pressure sodium lights are there on campus?
So we currently have 80 LEDs and 7 high pressure sodium lights on campus.
So can you tell us a little about the calculations that you've worked through as well as some of your findings?
Yes, so for the LEDs, they require about 35 watts to be powered. So we multiplied the 80 fixtures by 35 watts, and we got 2,800 watts, which can be converted to 2.8 kilowatts. We then, based on data from the hours of darkness in a given year, we multiplied the 2.8 kilowatts by 4,301 hours of darkness in the year 2017, and we got 12,043 kilowatt hours used for the 80 LED lights. And the same number was calculated for the 7 high pressure sodium. So in the calculations, you'll see that the 7 fixtures require 400 watts, but there's only 7, so because the watts is so high, it kind of counterbalances that. So the 80 fixtures use the same amount as the 7 fixtures.
Wow, that is incredible.
Yeah.
So were there any obstacles or limitations that you faced when trying to figure out these calculations?
Yeah, and it's something we really want to focus on because we can't just look at this and say this is the correct answer. So one of the first limitation is dawn and dusk are also considered times when these lights will be used, but it's not considered in the darkness hours that we used. Mm-hmm. So technically these lights will actually be used more than what we calculated. So that's something to consider. Also, there's a ballast in the LED lights which requires a fan, and that causes some inefficiency, and those calculations weren't put into this larger calculation. And also the lack of information from Green Mountain Power, we're still not 100% sure that the high pressure sodiums are 400 watts, but we're pretty sure that that's what it was.
Pretty confident in that. Gotcha. Well, that is a lot of energy being used with both LEDs and as well as high pressure sodium lights. Now, even though this is a rough estimate, the college can still use this information as well as each other to figure out how to make this college much more energy efficient. As Max and Elizabeth have said, the high-pressure sodium lights out back are not as efficient as they could be. In order to fix that and to follow GMC's mission for sustainability, we have to replace them with the LED lights that Max had suggested in the first place. It's important to be aware of your energy usage and recognize that all of these small changes can make a big difference in the future. Think about that as you make well-informed energy decisions in your life. Thanks for watching.